BASTA 2016 hier in der Mainzer Rheingoldhalle. Ich freue mich sehr, dass Barbara Fusinska Zeit gefunden hat, mit uns zu sprechen. Hallo Barbara.
Ja.
Barbara ist Data Solution Architect bei Microsoft und als .NET-Entwicklerin mit mehr als 10 Jahren Erfahrung hat sie sowohl in Startups als auch in größeren multinationalen Unternehmen gearbeitet. Und wie ihre Jobbezeichnung schon andeutet, ist Barbara überzeugt, dass Daten und die passenden Metriken ganz wichtig sind, ein wichtiger Schlüssel für den Aufbau und den Erfolg von Unternehmen. Wir wechseln jetzt aufs Englische und unterhalten uns auf Englisch ein wenig über Machine Learning und die dazugehörenden Prozesse. Barbara, today it's hard to imagine a successful business which doesn't make a profit from some kind of data prediction or data forecasts, like for example, people's shopping preferences or their taste in music or movies or anything or something like that. Please tell us about how you think machine learning technologies can help in making such predictions better.
So, if it comes to machine learning, it's usually a very overused word or set of words. And how can it help? It's not like machine learning is artificial intelligence, which people seem to think very often. I used to think that too. And what we think of artificial intelligence is also not what scientists are actually working on. So it's more like we're try to apply some stuff that are doing stuff more smart than hard rules. And machine learning is something that is not as good in thinking like people, but it's damn fast.
Okay.
So it can count, can calculate, and can do it quickly with a lot of data that human beings cannot grasp. And actual mathematical models were invented to feed those algorithms with data, fill those algorithms with models and rules, and they are just calculating stuff and predicting. What's prediction is making a conclusion from the data from the past, and it's a very vague idea.
That's the learning part, basically.
That's the learning part. So the idea of making conclusions from the past, it's a broad topic, but a base of what machine learning is. You've mentioned like recommendation engines. So this is actually a very good example of how we can understand what machine learning can do. So you're imagine there is no machine learning. Imagine there is no Netflix or Amazon that are doing this. If you're thinking of a human being doing this process, they need to seeing you or seeing that you're approaching the page, need to go through your history. And us as humans, we tend to think in patterns. We see, oh, this person likes sci-fi books, or this person does not really buy books, they buy computer games. So you're trying to find out what else do we have in stock or in our catalog, and then you can recommend something like this. But if you have several thousands, dozens of thousands of products, items in your data catalog, and God knows how many users, I wish you that if you have a startup, right? That's a good thing to have. It's just impossible for a human to do it. So what humans are coming up with are those rules, are those mathematical models. Machines are taking the data, plugging them in, and then can do those recommendations. Very often better than humans. Better than humans would ever done. I've just read an article about how, well, in the future machines, robots, or just algorithms will replace, maybe not humans, but some jobs that are, I would say, deterministic, that don't require this creativity and are just sequence instruction that we do in our jobs. And but we still don't believe that machines can do some predictions that we think are primarily human, like medical diagnostician. If you look at the research, people are really not keen to trust algorithms, even though there are studies that prove those algorithms are pretty good, much better than doctors. And it doesn't mean you should replace doctors. It should just mean maybe this specific job of diagnostic of breast cancer, for example, could be replaced by something by something automated.
Or could be assisted in a major way, basically, by machine learning. With Azure Machine Learning, Microsoft has also started a service for creating and then testing and operating prediction analysis in the cloud, of course. And the tool for all of this is Azure Machine Learning Studio. And you deal a lot with Azure Machine Learning Studio, and it's basically machine learning as a service. You could say that.
Yes.
Yeah.
That's
the goal of it. Yeah. Now, as far as I understand, there are a variety of data manipulation techniques in regard to or inherent in Azure Machine Learning Studio. And could you please elaborate on some of these special data manipulation techniques?
So they can go from simple stuff. If you're done some machine learning or some data manipulation in your life, you probably are very bored by some tasks, like you get, let's say, table of data, you have columns, you have rows, and you don't need all of the columns. So you need to just pick some of them. And you need to tell the algorithm that, oh, this is the column I will be predicting. And in the past, people were just writing those stuff by hand and try to make them very general, depending on the data type. And whenever I had to do it, I had the feeling like, this is such a dumb task. I shouldn't be doing it. It's 21st century. Something should be like standardized and doing it for me. And again, some misconception about Azure Machine Learning Studio is like, this is a tool more accessible to every level of developers, from developers, machine learning people, data scientists, also business people. But it doesn't mean it's easy. It's more accessible because it takes some of the tasks from you. And this data manipulation, I find it a genius, really stroke of a genius functionality, because I just tell this algorithm, those are the columns I don't want. Those are the columns I want to summarize. This is what I want to do with those columns. This is where I need to do data normalization. And I don't have to calculate it because it's really, really not an interesting part. The interesting part is the learning phase, not the data preparation. And if you talk to data scientists, they can tell you that even 90% of the time when they are working with machine learning is data preparation. Basically shaving the yak, not very pleasant activity, and they want to go to those more interesting parts, but they cannot if they don't have ready to use data. And this part I love in Machine Learning Studio.
Okay. There's also, you talked a little bit, or in what you just said, there was also the aspect of customization already a little bit. And in machine learning processes, there's the way to customize it is often by using so-called R modules from the programming language, as I now learned R. Can you explain us what these R modules are, some of their specifics, and how they are used for such customization?
So R modules is just another piece that you drag and drop. I've mentioned some of the pieces that could transform your data, but you can also drag and drop some other pieces like specific data, specific machine learning algorithms, or like modules that are scoring the model. And one of those pieces or those components of your machine learning algorithm can be something that you want to just do by yourself. Maybe you didn't find the module that is doing exactly what you wanted, or maybe you have an idea how to make something different. And this is where you drag R module. So R module is just a type of component. And what it does is allows you, it opens a space for you writing a code. So whenever something is insufficient, or you think it's better when I express it with the code rather than figuring out how to plumb all those components together, there you go. You have an R language, which is a broadly used language in the data science world, and you can write your own component.
Okay.
You can even write the whole machine learning part in R.
In this module?
Yeah. And you can have several of them and just pipe them together.
Now, when you're working with big data volumes, as far as I understand, there's a need to treat data a little bit differently. Basically, when handling data sets that which are basically too big to fit into memory, you go either and split them or stream them, and you use tools like Hadoop or Spark. How does Azure Machine Learning Studio integrate with those technologies? Does it?
Yes, it does. But again, without knowledge about those specific tools, you can just say it integrates with them. But how does it integrate? Machine learning in general, if we step out of Azure implementation, has like two inputs when you can think of a big data and machine learning itself. So Hadoop offers some libraries like Mahout for machine learning itself. And how does it work? Basically, with the learning part, it does divide and conquer stuff, because you can learn from big data set that does not fit in a memory. So you use those clusters, Hadoop clusters, to learn your algorithm. So this is when you are using Hadoop clusters in general for machine learning. But when you want to connect Hadoop and Azure Machine Learning Studio, there are two ways. Either you can feed Machine Learning Studio using Hive query. Hive query is a query written in Hive. This is a language that you can use to query through the cluster in your Hadoop. Or another thing is, if you publish your model as a web service, you can use it anywhere, including Hadoop, right? Because it's just web service, so you can imagine you can use it there with some other calculations that are doing something else than machine learning. While machine learning is in Azure ML. For example, you can stream data. Let's say you try to find out, I don't know, the fraud on the credit card. But the logic that actually recognize it is in Azure ML. But you have a stream of transactions, and for every transaction you're calling the web service with your machine learning algorithm, and this machine learning algorithm is predicting this is a fraud, this isn't a fraud. So several ways how can you think of big data and Azure ML Studio. Unfortunately, at least for now, for the time being, when you're thinking of feeding Azure ML Studio with big data set to learn it, it's only possible for 10 gigabytes. That's the limit.
Okay.
So it's barely big data.
Okay. In big data terms, that's basically nothing. You already mentioned web services, and another important aspect when dealing with big data architectures is, of course, scaling them. How does Azure ML Studio, or how do the Azure Machine Learning web services deal with such requirements of scaling, especially?
So also recently, there is a new way how you publish web service. So you have your model, you've trained it, and it's ready to go. And now you're publishing it. So it's basically a web service, an API that you can call in any system you want. And as you said, there is a matter of scaling. Imagine those online transactions from credit cards. This is big data we're talking about. So the classic way allowed you to do like 20 to 200 transactions, requests in parallel. And whenever you wanted more, you needed to add another endpoint, and deal with it with load balancer, etc. The new way of deploying Azure ML is just you're picking up your pricing model, and it's just a matter of the price. It can go to 50 million transactions per month. But yeah, if you need more, you can get more. And it's from what I was researching, it's a pretty cheap service to buy.
Thanks, Barbara, for your insights. I think we'll get to know much more about machine learning in the future, and there's lots of stuff to discover. Thanks for talking to us, and have a nice conference.
Thank you for inviting me.